Welcome to another class. Today we'll discuss about the complete extraction process of iron from its ore. Okay. Here, as we have already learned about the different methods used for extraction of any metal from its ore, the different steps like crushing and grinding, concentration, then after formation of metal oxide, then thereafter the reduction of metal oxide to form metals, and then the refining of crude metal to form pure metal. Okay, today we'll try to discuss completely the process of extraction of iron. Before going through the extraction process, we have to learn what are the main important ores of iron. Okay, iron is very reactive. We know that iron is come after carbon. It's found in nature in pure form, and other ores like oxides, carbonates and sulfides, and it is come as second position in occurrence inside or above the earth crust. Okay, the main ores of iron are hematite, Fe2O3, magnetite. Magnetite, its spelling is TITETE, magnetite, Fe2O4, iron pyrites, FeS2. Whatsoever, we only concentrated on the ore, that is hematite. It is the most important main ore of iron is hematite, from which we can extract iron in higher amount. Okay, that is in 3 oxidation state, iron in 3 oxidation state, Fe2O3. Here this ore contains many impurities such as silica, that is silicon dioxide. Okay, that is in form mud or sand. Since iron is below carbon in the reactivity series, iron in the ore is reduced to iron metal by heating with carbon such as coke. We'll discuss in the reduction process elaborately. Okay, now what are the steps used for extraction of iron? Step 1, we already know. The first step is grinding and crushing and grinding. However, we need not to mention always the crushing and grinding process. It is mentioned in this concentration process only. First we crush the ore, the lump of ore in jaw crushers and broken into small pieces like 2.5 centimeter. It is concentrated by gravity process followed by magnetic separation method, because since hematite or Fe2O3 is a magnetic compound, that's why magnetic separation method is used. We have already discussed what is the magnetic separation method. Okay, so need not to explain here itself also. So magnetic separation method, in which it is washed with water to remove clay, sand, etc. And in magnetic separation method, all the non-magnetic compound will go off in another container, and magnetic ores will remain in another container. Okay, now second step is, after concentration, second step is calcination. We have already discussed what is calcination. Here in extraction of iron method, calcination is generally used calcination is used because here calcination is used because here some impurities like iron carbonate is also there. So calcination is used to remove the moisture and any other volatile component at very high temperature below its melting point, and the decomposition of carbonates into oxide. Then ferrous oxide is converted into ferric oxide by roasting method also. Here the reaction is FeCO3 converted to FeO, ferrous oxide, plus carbon dioxide. Carbon dioxide is volatile compound, that is volatile compound means gaseous component that will go in the air. Then this FeO is oxidized or roasted through in presence of excess of air to form Fe2O3. This is in 3 oxidation state ferric oxide. This ferric oxide will use for our next step. Okay, so after the second step we will go for smelting, that is reduction of iron oxide into iron. In this step, since we have already known that in smelting carbon is used because carbon is more reactive than iron, so here carbon is used as reducing agent. So in this step the concentrated ore is mixed with calculated quantity of coke. Coke, you know, coke, that is Agar, and limestone, and the mixture is put in the blast furnace from top. Blast furnace mane ahomiyat koi marut chulli. Marut chulli eta enekwa eta apparatus, it is used for extraction of iron. Here this is the structure of blast furnace. It is a cylindrical tall furnace made of steel. Okay, made of steel, and the inner lining is made of fire bricks. Fire bricks mean, you know already, fire bricks mean jibur ita, jibur itar bhata jitu joli thoka ita, tenekwa dhonor ita yade lining ot byabohar kora hoy. It is narrow at the top. Tamane tumar amar jeneke tumar cup eta thoi loa eta kapor nisina upor phale olop thek, and wide at the narrow, wide at the bottom of this furnace, and there is an arrangement of for introduction of ore, and in the upward position of the furnace dekhisa upor pra ami dibo porake, ami add koribo porake eta arrangement thake. Then and in the bottom there is an arrangement for removal of waste gases, for removal of the molten iron or molten metal or slag in the bottom of the furnace. And another arrangement is there for the removal of waste gases. So you are watching what are the different zones in the blast furnace. There are different zones in the blast furnace. This downward zone is the highest heating component. Here the temperature is very high. It is around 2000 degrees Celsius. Then going through the upward, temperature decreases. Okay. Through this source equipment, we will add roasted ore, because we have already calcined or roasted the ore. Then we will add fluxing stone, that is calcium carbonate or calcium oxide. Then coke. Coke, you know, coke is carbon containing material. Okay, that this is the blast furnace apparatus. Then after knowing the apparatus, we will go through the reactions, what will happen in the reactions. Okay, first the downward zone, that is at around 2000 degrees Celsius. As we have added carbon containing compound coke from the upward zone of the furnace, and here hot air, blast of hot air is passed through this tire. This from this tire, and another tire is also there. As from both these tires will pass hot air gas. Okay, this carbon and hot air gas will react to form carbon dioxide. Okay, first carbon dioxide is generated from the hot air gas and upward carbon. Then this carbon dioxide gas will react with another coke, then it will form carbon monoxide. This carbon monoxide gas will go upward, so that this this furnace will be heated up. Okay, this furnace will be heated up, and this carbon monoxide, when it goes to upward moment, then there are different reactions will happen. Okay, first reaction is combusting zone, that is the downward zone. This is the lowest part of the furnace. In this region, temperature varies from 1500 degrees Celsius to 2000 degrees Celsius. Here, carbon from coke and oxygen from hot air will react to form carbon dioxide. Then this produced carbon dioxide would react with coke to another coke to form 2 molecules of carbon monoxide. Okay, this carbon monoxide, this formation of carbon monoxide in the furnace releases the temperature 1875 degrees Celsius. Okay, now the second step is upper zone of reduction. We know that here the smelting is going on, so reduction is going on. The reduction happens in the upward moment, that is from 800 degrees Celsius to 1000 degrees Celsius. Here we will see from 250. Since the topmost zone of the blast furnace, that is from 200 degrees Celsius to 800 degrees Celsius, the reduction will happen. This reduction process happens in the upper part of the furnace. The temperature is between 975 degrees Celsius and to 1075 degrees Celsius. Here, hematite is reduced by iron by carbon monoxide. The molten iron is collected at the bottom of the furnace. Okay, now what are the reactions? We will see that this hematite Fe2O3 will react with carbon monoxide. Carbon monoxide is a reducing agent, that it forms Fe3O4 plus carbon dioxide. Then again Fe3O4 will react with carbon monoxide to form FeO, ferrous oxide plus carbon dioxide. This ferrous oxide will react with carbon monoxide. The carbon monoxide which is produced through the formation of carbon dioxide and coke. Okay, this carbon monoxide will heat it up this furnace. So in everywhere carbon monoxide is there. This carbon monoxide will react with ferrous oxide to form iron and carbon dioxide. This iron is in impure form, that is in molten iron. Then this iron will contain some impurities. Okay, now we have already stated that some flux is also added, that is calcium oxide is also added. Okay, calcium carbonate, that is limestone, is added. What is the action of limestone? So we have to mention also these actions. It acts as flux to remove sand from hematite in form of liquid slag. That means liquid slag is molten slag, and it can be removed through the some pipe, so that we can get a molten metal. In the range of the temperature 1000 to 75 to 1275 Kelvin, in the middle of the furnace, that is at the middle of the furnace, this is the region 1000 to 1275 Kelvin. At this region, calcium carbonate, which is from limestone, will react with undergoes decompositions, and that means because heat is everywhere in the system, so this carbon dioxide will react with heat to form calcium oxide and calcium oxide plus carbon monoxide. Calcium oxides will react with silicon dioxide, that is what is impurities, to form calcium silicate. This calcium silicate is known as slag, because calcium oxide is flux and silicon dioxide is impurities, and flux and impurities to give slag. This slag is molten state, and this can be driven off. Okay, since slag is lighter than molten iron, so it floats over molten iron and protects it from oxidizing back into its oxide. That means slag is lighter than the molten iron. Okay, slag is lighter than the molten iron. Okay,